7 is written where James wants to travel to Pitland to St. Luke's, so from here to here. But he could pass through Q or R on the way, correct? Is he going to pass through Q and R? That makes no sense. That means like he's going to like hit here, but then he's like, nah, I'm going to go back and then I'm going to try again so that I go through R. Like no one's going to do that, correct? So we can use the fundamental counting principle in this way because the fundamental counting principle states that if you have different parts that make up the whole thing, you can take the amount of parts here and the amount of parts in part 2, or amount of outcomes in part 1, amount of outcomes in part 2, multiply them and you get the total number of outcomes. We agree? So going from P to S through Q has 2 parts, correct? Part 1 has how many? How many outcomes do we have in part 1? Options. From P to Q. 2. From Q to S, how many do we have? From Q to S. 3. Now I need to go through P, use the ones from P and the ones from P to Q and the ones from Q to S to get to S, do I not? It's and, so I have to multiply. If you say or, you're saying I could go to P to Q or I could go from Q to S and I get to S, which doesn't make any sense. You have to go through both of them. So that's going to be 6. So there's 6 ways that you could go from P to S through Q. Now what about the other option? P to R has 3, R to S has 1, and 3 times 1 is 3. Most people can get to that point, but then they don't know now, should I multiply the 6 and the 3 or add the 6 and the 3? So we have to decide, is it and or? Do we have to take these paths on the top and these paths on the bottom to get to S? Or can we take these paths on the top or these paths on the bottom to get to S? It's or, right? It's either these ones or these ones. So what are we going to do with those 2 numbers? Add. So there's 9 different routes from Pitland to St. Luke's. Okay, then we're going to flip over. Nope, I missed a page. We're going to go to extension 9. So example 9, sorry, from extension 5. So yesterday we did, and this is, I don't want to lose you. This is going to be the hardest thing for today. Okay, this question, this example. So I don't want to lose you. I want to keep you. I don't want to lose you. Okay, so example 9 is an extension of example 5, which we did yesterday, which was the 4-digit odd numbers, correct? We agree? We're now going to do the same question with 4-digit even. So how does that change the question? So this one's 4-digit even, says nothing about not repeating, so we can repeat, right? We agree? So our back number has to be a what for it to be even. What numbers could it be? 2, 4, 6, 8. Anything else? 0. So I have 5 options. Do I need to box one of those? No, because I can repeat. Correct? What about the first blank? Can't be 0, so it can be 1 to 9. And it can't be 0 because it says digit number, not digit code. If it was a code, it could totally be 0, right? So I have 9 options. And then in the middle, I have 0 to 9, which is 10 and 10. So it's 4,500. So that makes sense. There's the same amount of even 4-digit numbers with repetitions as there is odd 4-digit numbers. Yesterday it was 4,500 as well. The problem lies in the non-repeating issues. Okay? Yesterday we didn't have a problem. When it was odd, the only thing we needed to remember was we started with the back 1, 3, 5, 7, 9, which was 5. We held the 9, then we'd have 1 to 8, which was 8. The only thing we really needed to remember was that we had to bring back the 0, correct? And then it would be 1 to 7, which is 8, and then we'd have 7, right? That was yesterday. No big deal. No big deal because no matter what we picked here in the last blank, and no matter what we picked here in the first blank, 0 always came back, correct? Because 0 wasn't an option for the back because it would needed to be odd. And 0 wasn't an option for the front because I can't start with a 0. We agree? What's the issue though now when we do evens? Is the 0 always guaranteed to come back in that second blank? No. When would there be a problem where that 0 wouldn't come back? With an even. When would be the error where we couldn't bring that 0 back? We've already used it. It would end in a 0. Yeah. So if it ends in a 0, we've already used the 0. It's not coming back in the second blank, correct? But if it ends in a 2, a 4, a 6, or an 8, are we still good? And a 0 would come back, wouldn't it? So we have to do 2 separate cases. We have to do a case where the back number is a 0, then 0 can't come back in that second blank, correct? Or a case where it's a 2, 4, 6, or 8, and then the 0 can come back. We have to do 2 separate cases when it's even, non-repeating. Okay? So that's the key thing here. Even 4-digit number, not repeating, you need 2 cases. You need a case where it ends in a 0, or a case where it ends in a 2, 4, 6, or 8. Because you have different options if it ends in a 0. You can't bring the 0 back. It's been used up. If it ends in a 2, 4, 6, or 8, you bring the 0 back. Does that make sense? Okay, let's try it out. Case 1, or we could have case 2. So we add cases. When we have numerous cases and options, we add them because we want one 4-digit number. So we're going to have either this 4-digit number or this 4-digit number. So that's why we add them. All right? So one case, we end in a 0, or the other case, we end in a 2, 4, 6, or 8. If we end in a 2, 4, 6, or 8, a 0 is coming back here. So I'm going to put a 0 there right away so don't forget to bring it back. Because I didn't use a 0 in the last blank, in the end digit, and I'm not going to use a 0 in the first digit, so it's going to come back, right? Here, I'm using a 0, so it's gone. I'm not going to get a 0 back. Does that make sense? You have to do it in 2 separate cases, because if I use a 0 at the back, no 0 comes here. If I use a 2, 4, 6, or 8, I get a 0 option back in the second blank because I haven't used it. Okay, so let's do the 0 option first. How many options do I have at the back? 1. It's a 0. How many options do I have in the first blank now? Because I have to do that next. Because I have a restriction on it that it can't be a 0. So it's 1 to 9. We agree? Which is 9 options. Then say I use the 1. Then it would be 2 to 9, which is 8 options. Say I keep the 2. 3 to 9, which is 7 options. We agree? Now, what if we use 2, 4, 6, or 8? How many options do we have at the back? 4. Say I keep the 2. Now I would have 1 and then 3 to 9, which is actually only how many? 8. Totally different amount of options, correct? So if I pick a 2, 4, 6, or 8, I have 8 options at the front. If I pick a 0, I have 9 options at the front. That's why I can't do them together, because they end up with different options. So you have to do them as 2 separate cases, because they're going to end up with different results. Now I bring the 0 back. Let's pretend to keep the 1. I have 3 to 9. So it's an 8. Keep the 0, 3 to 9. It's a 7. So what's 9 times 8 times 7? Anyone? Bueller? 504? Plus 8 times 8 times 7 times 4? What'd you get? And when you add them, 2,296? Do you understand the difference if it's even, non-repeating, and odd, non-repeating? Odd, non-repeating, you can have 1, 3, 5, 7, 9, and then you'd have one of them cut off here, right? You could do it as one case. Even non-repeating, you have to do two cases, where it ends in a 0, or it ends in a 2, 4, 6, or 8. I would star this one because this is the one that everyone forgets about. We're going to look at example 10. Consider the number of distinguishable four-letter arrangements that can be formed from the word English. So when I have the word English, it assumes that there's no repetition because it's like you have Scrabble tiles. You have one E, you have one N, you have one G, you have one L, you have one I, you have one S, you have one H. Okay? So people are like, well, I have seven E's. Do you really have 7 E's? No, you have the word English. So you have what the word English has. One E, one N, one G, one L, one I, one S, one H. They're not going to say it can't repeat. Because sometimes it can repeat. What if you had the word pool? You'd have a P, you'd have 2 O's and an L, right? Totally different. Okay, so we have to read thoroughly. It says, consider the word English. When given a word, it is assumed you only have the letters contained in that word, the amount of times it occurs in the word. Determine the number of distinguishable four-letter arrangements. So we have to watch. Sometimes they use the whole word. Sometimes they only use 4 of the letters, or 5, or 2. So we have to read. And distinguishable four-letter arrangements means they look different. Okay? And when you have a word that has no repetition, they'll all look different. Because E-N-G-L, G-L-E-N, they would all be different words. Okay? So any letter can be in any position. So how many options do I have for this first blank? 7. I have E, N, G, L, I, S, H. So I have 7. Then I have to keep one there. So then I would have N, G, L, I, S, H. 6. Why don't I have 7 times 7 times 7 times 7? Yeah. Right. Yes. Exactly. When I use a letter, I can only use it once. So I have the E. I used it. I don't have an E anymore. So now I have 6. N, so G, L, I, S, H. 5, H, G, L, I, S. 4. What's 7 times 6 times 5 times 4? Another way we could do this question is 7 letters, P4. I have 7, I pick 4. And the reason why it's a P is because this is a permutation question. If it was a combination question, I would use a C, and I'd have less options. But it's a permutation because words are always permutations. Order matters when it's a word, correct? So if you have a number, and you say you do fundamental counting principle, and you started a number and you go down by 1, you can always use P. 7P4 will get you the same answer. The first letter must be an E. So this has to be an E. How does it change the question? What do you get in the first blank? 1. How many letters do I have left? 6, then 5, then 4. Just 120. This one I could represent by 6P3 because it starts at a 6, it goes down by 1, 3 blanks. It'll get you the same answer. The first and last letters must be vowels. So the only vowels I have are E and I. So I could have E and I. So 2, hold the E here, I. So 1, and then how many letters do I have left? 5, because I left 1 letter here, 1 letter here, 5, 4. D throws people off because the word must contain a G. The word has to have a G somewhere in it. Okay? So put 4 blanks. You put the G where it is. Where do you think the G is? You put a G below the blank. Go. Most of you, due to an orderly fashion, will put the G here. We agree? But where else could it be? Could be in the second blank. Where else could it be? In the third. Where else could it be? In the fourth. So we're actually going to have how many cases? 4. One where it's in the first, second, third, fourth. So we have this, or cases means plus, a G in the second, or a G in the third, or a G in the fourth. So I have one option for here, then 6, 5, 4. I have one option for here, then 6, 5, 4. One option for here, 6, 5, 4. One option for here, 6, 5, 4. So it's 480. If you notice, it's 120 plus 120 plus 120 plus 120. Or what could you have just done? Each of these is 120. So we could have done 120 times 4 because it can move into 4 different spots. So the rest of the questions to try will be for homework, and we're moving on. So you'll be able to do the rest that I didn't give you. We're moving on to factorial. So factorial symbols just mean what? Start at that number, down by 1 all the way to 1, correct? So if I give you 7 factorial, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and I'd stop at 1. We agree? But if I gave you n factorial, you would just continue to go down by 1 until you get to 1, but how do you know when you get to 1? You don't. So you would just keep going. So we'd start at n, and then we'd multiply it by 1 less, n minus 1. And then we'd multiply it by 1 less, n minus 2. And we'd multiply it by 1 less, n minus 3. And it would just keep going on for life, correct? Because we don't know when it's going to hit 1 because we don't know what n is. So now we're going to go through a few other questions. So what if I give you this? N plus 2 factorial over n factorial. And they're not going to ask you to simplify this, but this is a step before we have to actually do this. So if we can't simplify this, we're not going to be able to do the big questions like this that they give us. Okay, so let's look at this. Simplify the following expression. Leave the answer in product form where appropriate. Do not expand. So which one of these, if I expand it, would encompass the other one? So n plus 2, 1 less than n plus 2 is what? What's 1 less than n plus 2? N plus 1. So if I went to expand this top out, I get n plus 2, 1 less, n plus 1. What's 1 less than n plus 1? N. What's 1 less than that? N minus 1. And it would keep going, wouldn't it? On the bottom, we have n factorial. So we start off with n. And then what's 1 less than that? N minus 1. And I would keep going. We agree? Instead of putting the dots, like I have, do you see how I have the dots? It keeps going. What you can do is you can put a factorial symbol instead of these dots, because the factorial symbol just means it keeps going. We agree? So instead of the dots, I could have put a factorial symbol. Why did I stop at both those spots on both of them? What's in the top and the bottom now? John? Right. You can cancel the n's, and you can cancel the n minus 1 factorials or the n minus 1s and dots, right? But they would rather see factorial symbols than dots because it's not proper math. So now this top one was bigger than this one, wasn't it? This top one contained this bottom one, didn't it? So we'll always expand the bigger one out till it contains the smaller one, and then they can cancel off. So now this n minus 1 factorial, n minus 1 factorial cancel off, and I'm left with n plus 2 times n plus 1, and we're just going to leave it like that for now. So really, we're trying to get rid of those factorial symbols by taking the bigger one and expanding it to cancel off the smaller one. So which one's bigger here, n minus 2 or n minus 1? N minus 1 is actually bigger because it's the next one when I expand it out is n minus 2, right? Because we're just going to take one off. So I'm going to start expanding the bottom one first because it's bigger. N minus 1. What's 1 less than n minus 1? N minus 2. You're just subtracting 1 off of it, correct? And then 1 less than n minus 2 is n minus 3. And then I'm going to go factorial symbol, because I could just go dot, 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 but it doesn't look as pretty. On the top, I'm going to start at n minus 2. What's 1 less than n minus 2? N minus 3. And because it matches the bottom now, I'm just going to put a factorial symbol. Is everyone following me to that point? Yeah, no? Okay. So now we can cancel off what's the same. N minus 2, n minus 2, n minus 3 factorial, n minus 3 factorial. And a whole bunch of people tell me the answer is n minus 1. The answer is not n minus 1. It's, what is it going to be? Yes. So these cancel off. Every single time you cancel, I don't know if you've known this, but every single time you cross off something, they're just ones. Like these are all just ones, little slanted ones. Correct? So this is technically 1 times 1, so what's left on the top? A 1. And then on the bottom, you have n minus 1 times 1 times 1, which is n minus 1. So that's why you actually are left with that 1 in the numerator. Because every time you cancel, you aren't left with zeros, you're left with ones all the time. Yeah. Absolutely. I'm showing the n minus 3 just so people don't get lost. But you could have went to n minus 2, they overlap, cancel, done. Absolutely. Okay, C, the only one that has a factorial is actually the n factorial, so I know it's the only one I can expand. So n factorial is n, 1 less, n minus 1, 1 less, n minus 2 factorial. This one I have to actually go to n minus 2 factorial, because what some people try and do is they go like this, n minus 1 factorial, don't write this, it's bad, n minus 1, and then they have this. Is a factorial symbol sitting by itself actually a factorial symbol? That's an exclamation mark. It's great, it's beautiful, it's not helpful to us at all. It needs to have something in front of it in order for it to be a factorial symbol. So it has to have like a 6 or a 7 or an n minus 1 or something in front of it to be a factorial symbol. If it doesn't have something in front of it, it's literally an exclamation mark, which is, I don't know, it's screaming. That's all it's doing. It's screaming because it's sad, because you did something bad. Okay, so she gone. So I have to go to one more so that I can actually cancel these off. Okay? So why are we doing this? Why is this helpful? Well, we have these lovely, this is 30-2, we have these lovely formulas over here, which are on the 30-2 formula sheet too, because you guys both do prims and comps. The NPR formula is n factorial over n minus r factorial. The NCR formula is n factorial over n minus r factorial. So, like today in our quiz, you guys were missing the n, correct? I didn't give you the n. You literally just plugged it into your calculator, which is a smart way of doing it. You got the answer as a multiple choice, you were fine. But if that was a written response, you'd get 0.5 out of 3, which would suck, because they'd say algebraically and you did nothing algebraically. They're actually being generous if they give you a 0.5. They could give you a 0 and still be completely okay with doing that. So we're going to go over this n factorial over n minus 2 factorial. We have a formula. It's NPR equals n factorial over n minus r factorial. We agree? Well, this one actually has a 2 in the r spot, doesn't it? If you look here, there's a 2 in the R spot. So this is actually the same as saying NP2 equals 42. This here is NP2, is it not? The N stays an N, the R becomes a 2. So NP2 equals 42. It looks a lot like the question you guys were doing on your quiz. So let's expand this out. Which one's bigger, n factorial or n minus 2 factorial? Which one encompasses the other? Which one's bigger? The n factorial or the n minus 2? Which one, if I expand it, would contain the other one? N factorial or n minus 2? N factorial. Because if I expand it out, you'll get n minus 2 factorial, correct? So I'm going to get n bracket 1 less, n minus 1, 1 less, n minus 2 factorial over n minus 2 factorial equals 42. These cancel. And now I'm left with n bracket n minus 1 equals 42. If you're someone who hated quadratics in 20-1, by the end of the year, not the unit, end of the year, you'll be like, how did I think it was hard? Because we use quadratics in every single unit. Every single one. So you have to be able to solve a quadratic like that, because it's going to be used all throughout the year. So this is a quadratic. Why is this a quadratic? Because it's a degree 2. Why is it a degree 2? Because I need to distribute that n in, correct? So I'm going to get n squared minus n equals 42. If I was solving this question and at any point in time I skipped any of the steps I'm doing right now, they will take off marks. So do not be a skip stepper. Not good. Okay? Now, it's a quadratic. When I solve quadratics, what's the very first step I have to do? Move everything to one side and set equal to 0. Every single time. That was pushed all last year over and over and over. So I have to move that 42 over. N squared minus n minus 42 equals 0. And now we're going to factor. If you're like, factoring is a swear word in my life, I don't know how to do it. There's a time and a place where you have to come to terms with the fact that you need to learn how to factor. And you need to learn to admit it to a teacher that you don't know how to factor. Today's that day. Like, come in and schedule help at lunch. I don't care if you have to sneak up and whisper it or slide it to me by paper and say, I have no idea how to factor. You need to admit it and need to learn how, or this year is going to be awful because we factor trig equations. We factor log equations. We factor. So if you can't factor, today's the day to admit it. Even if you have to slide it in a piece of paper to me, like you can't speak it, if you can admit it, right? Okay. So we have a 1 in front, so we can go directly to brackets. An n in front, an n in front. And then you say, what times what equals 1 times negative 42? Negative 42. So the multiply. It multiplies to the outside, adds to the inside. What's it going to be? What multiplies to give you negative 42 and adds to give you negative 1? Negative 7 and positive 6. So I get n minus 7 and n plus 6. And that's not answers. We have to take both those factors, set it equal to 0, and solve for n. This is grade 11. N minus 7 equals 0. N plus 6 equals 0. Move the 7 over, n equals 7. Move the 6 over, n equals negative 6. Now let's remember from our rules from before. Can I have a smaller number here than here? Can I go like negative 7 numbers and I pick 2 of them? That means I have negative 7 letters. That means I don't even have letters. I have so many that I have negative 7 letters. And I'm going to pick 2. Does that make any sense? No. So if I take this negative 6 and I plug it in here, negative 6p2, does that even make sense? Would your calculator be like, yeah, I'll give you an answer? No, it would be error. Okay. So if I plug this into here, I could check it. -6 factorial. Is there such a thing as -6 factorial? Now remember I told you when it has a factorial symbol, you have to start at a number and you go down by 1 until you get to 1, correct? No negatives are ever allowed in a factorial symbol. N minus 1 is allowed because we don't know what n is. N could be 10. 10 minus 1 is still 9. We're still fine, right? But the number itself cannot have factorial. So if I plug this back in and check it, I have -6 factorial. Okay, that doesn't make sense. This can't happen. It's called extraneous. So that means it's no good. 7 factorial over 7 minus 2 factorial is 7 factorial divided by 5 factorial, which is 42. So I checked it. It works. It's good. My answer is 7. Could I have went 7p2 and got 42? Yes. Would it have given me any marks on a written response? Maybe not even 0.5. Okay. Oh, you guys have more. I don't know why this is cut. Where's my factorials? I didn't print the other one off. Okay. I don't think it has it on here either. All right. Let's go down to these bad boys down here. We're going to look at number 2. These are going to be your homework for today. And by the way, 1, 2, and 3. These are the answers. And then those 2 extra questions on the questions to try. We're going to look at not A, because you've done it before. Not C, because you could do it. We're going to look at B. Yeah. So B, we need to have our factorials onto one side so we can simplify them off, correct? So what's our problem with B? 2B. Factorial on one side, factorial on the other side, correct? So what could I do to get them together? Equals number, because that's what we want. This is attached to the 6 by what symbol? What mathematical operation? Multiplication. How can I move a multiplication to the other side? Divide. So now I'm at n plus 1 over, if you haven't noticed, you don't have enough room to do it here, so don't attempt to. You will not have enough room. Equals 6. And now we can do it, right? We'd expand the n plus 1 out because it's bigger. And then we're going to do all the exact same steps we did before. Where do people get messed up here? Not being able to solve a quadratic or factoring. It's not the perms and coms questions that people are bad at. It's the factoring and the quadratic solving. So it's grade 11 that'll get you. Okay? So we need to practice so that grade 11 doesn't get us. So 1, 2, and 3 are your homework. This one here, we have to plug into the actual formula on your formula sheet. So I'll set you up for this one. N factorial over 84. This is the NPR formula. So NPR equals N factorial over N minus R factorial. So this is N. I'm going to input that for all the N's. I'm going to input that for all the R's. So I'm going to get N factorial, which is N minus 2 factorial, over N minus R factorial. So N is N minus 2 minus N minus 4 factorial. I screwed up. Where did I screw up? What did I not do? Yeah. Brackets on where? Right. This N minus 4, I didn't actually subtract the whole R, did I? I just subtracted the N. I have to subtract the R. So whenever you're subtracting and there's more than a monomial, so one term behind a subtraction sign, you have to remember to distribute. We're taught that starting in grade 9. So we're going to get N factorial over 84 equals N minus 2 factorial over This would end up being n minus 2 minus n plus 4 factorial. So what am I going to get on the bottom? That cancels. That cancels. Negative 2 plus 4 is 2 factorial. What's 2 factorial? Two. It's just the number minus 1 to 1. So 2 times 1 is 2 factorial. So it's just 2. So if you wanted to not even write the factorial to screw you up, put it at 2. And then we need to get our factorials to one side. So we can move this over here by division. We can move this up here by multiplication. So that's your homework 1 to 3 and those other 2 questions, I think 7 and 8 on the questions to try from before.